Good morning. Let us start with what we did in last lecture. So in last lecture we considered a point P whose coordinates were x, y, z. So this is in Cartesian coordinate system. Then we knew that x is a function of u1, u2 and u3. Similarly, y is a function of u1 and u2, u3, and z is also a function of u1, u2, u3. So I wrote a position vector in Cartesian coordinate system j cap plus z k cap. Now, as x, y, z are function of u1, u2, u3, I can say that r bar is also function of u1, u2, u3. u1, u2, u3 are curvilinear coordinates. Now, suppose that point P shifts from some position to another and there is a change in r bar. That will be r bar plus dr bar. So dr bar is change in position. I can write dr bar in terms of partial derivative dabba r bar by dabba u1, as r bar is a function of u1, u2, u3 du1 plus dabba r bar by dabba u2 du2 plus dabba r bar by dabba u3 du3. So I wrote complete derivative in terms of partial derivative. You can see here r bar, I took derivative with respect to u1, here I took derivative with respect to u2, and here I took derivative with respect to u3. Now I can write it in terms of summation. So this is dr bar is equal to summation running over I is equal to 1 to 3 dabba r bar. Here you can see here is a 1, here is a 2, here is a 3. So rather than that I will put I, so some I and dui. Okay, if I try to expand this, let us see what we get. We should get this equation again. Okay, so let's try that. Dabba r bar by dabba, first I will take value 1, so that will be dabba u1. Here also it will be du1 plus dabba r bar. Now I took 1 here, so I should take value 2, so it will be dabba u2 du2. You can see I is here, now I is 2, so it is 2, and then I can write dabba r bar by dabba ui, now I is 3 du3. So you can see I am getting similar equation, so I can write it in terms of summation. Now we also saw that dabba r bar by dabba u1 is a vector. Because r bar is a vector, so derivative of r bar with respect to u1 will be vector. I can write any vector in terms of magnitude and some unit vector along that vector. So that is e1 along this dabba r bar by dabba u1, and its magnitude will be dabba r bar by dabba u1. Now I will show a picture to you. Not a picture, this is a diagram. Okay, we will take it to next page. This is x coordinate, this is y coordinate, this is z coordinate. This is some point P. In curvilinear coordinate system, there will be coordinate lines. So these coordinate lines are, I will call, this is one coordinate line, this is another coordinate line, and this is a third coordinate line. This is u3 curve, okay, this is u2 curve, and this is u1 curve. As you know, that intersection of u2 plane and u3 plane will give you u1 curve. Now if I draw a tangent to u3 curve to u2 curve, and to u1 curve, it will have some direction, okay? And drawing a tangent means taking a derivative, so they are similar, and this is e3 cap, this is e2 cap, unit vector along that tangent, and e1 cap. So e3 cap, e2 cap and e1 cap are unit vectors along the tangents drawn at point P to curves u3, u2 and u1 respectively. So now we understood that e1, u2 and e3 are unit vectors which are along the tangents which are drawn to the curves u1, u2 and u3. Now let us write it again. Delta r bar by delta u1. So this was a partial derivative of r bar with respect to u1. I can write it as, in terms of magnitude and unit vector, that will be delta r bar by delta u1. This is a magnitude, and e1 cap. So I can write it h1, some h1, okay? Rather than writing delta r bar by delta u1, I am replacing it by some h1, and there is e1 cap. Similarly, I can write for delta r bar by delta u2. This is the derivative of r bar with respect to u2. That will be the partial derivative because r bar is a function of u1, u2 and u3. So this will be the magnitude e2 cap, and I can write some h2 e2 cap. Delta r bar by delta u3 mod of delta r bar by delta u3 e3 cap is equal to h3 e3 cap. Okay, here we got some constants, h1, h2, this is 2, h3, these are some constants, so we will call them scale factors. Now we will try to define a length element. So length element dl square is written as dr bar dot dr bar. I know I already wrote dr bar as in terms of summation, so it was like this. So here we wrote it in terms of summation, but now here I have 2 dr bar, so I am going to change the index. So we will do it on paper. Summation I over I running from 1 to 3 delta r bar by delta ui dui, right? This is for first r bar, then dot, that is a dot product between them, then I. So now if I put I, then it will be the same index and it will make confusion when I will be treating them together. So I will put this index, rather than putting I will write j. J is running from 1 to 3 delta r bar by delta uj duj. Okay. Next I will collect the terms and I will collect the summation running to 3 and summation over j running from 1 to 3. Then I will collect the partial derivative terms delta r bar by delta ui. This is a vector, so dot product between the vectors. So I'm going to put dot here. This dot is here. Dabba r bar by dabba uj. Now this term, you can see first summation is here, second summation is here, first partial derivative is here. As partial derivative is a vector, so I am going to put dot product here. Here you can see dot product is here, then second partial derivative, and then remaining terms dui, duj. Again, I am going to introduce a new term, say gij, which is equal to dabba r bar by dabba ui dot, there is a dot product, so I will put here dot, dabba r bar by dabba uj. Now we will see separately, there are 3 into 3, so 9 terms will be there, so we will put them separately. So first let us start with I is varying from 1 to 3, j is varying from 1 to 3. So first I will keep I as a constant, okay, I is 1, then g1 and j is 1. So I will get term dabba r bar by dabba u1 dot dabba r bar by dabba u1. So that term will be square of this dabba r bar by dabba u1 square. Let's write the second term, that will be 1, 2, I is 1, j is 2. So that will be dabba r bar by dabba ui, I is 1, so 1 dot is there, and then dabba r bar by dabba uj, j is 2, so this will be the second term. Similarly, we will write third term 1, 3, which will be dabba r bar by dabba I is 1, so it will be 1 dot dabba r bar by dabba u3, because j is 3. So I can similarly write other terms. Then I fix 1, now there is a 2, and then I am going to vary j again, so 2, 1 dabba r bar by dabba u2 dot dabba r bar by dabba u1, then again 2, 2, that term will be dabba r bar by dabba u2 square. As you can see, first term was square, so 2, 2 is square, 1, 1 is square. G 2, 3, that will be dabba r bar by dabba u2 dot dabba r bar by dabba u3. Then 3, 1 will be there, because j can run from 1 to 3, so 3 is finished. So I will start with I is equal to 3, j is equal to 1, so that will be dabba r bar by dabba u3 dot dabba r bar by dabba u1. We will take it to the next page. Now we were working for 3 to dabba r bar by dabba u3 dot dabba r bar by dabba u2. G 3, 3, that will be dabba r bar by dabba u3 dot dabba r bar by dabba dot u3. So it will be square term, right? As you can see, there is a 3, 3, so I can write it as square term. Okay, so I got this gij. We were finding gij, right? So there are 9 terms of gij. So I can write length element as dl square is equal to g11 du1 square plus, so again we will go to the last page and we will see what we did. We defined this term as gij, okay, and now I am expanding this summation using this gij. Rather than writing this, I am going to write gij. So I will do it here. G12 du1 du2, g13 du1 du3 plus g21. Now I am going to vary I, du2 du1 plus g22 du2. Now there will be square, then g23 du2 du3. Now value of the I will be, I am writing gi, so I will be, here is a 1, here is a 2, here it will be 3, then j will be 1 dui, so I is 3, duj is 1, 32 du3 du2 g33 du3 square, because there are 2 3, so it will become square. So this is the expression for length element. Let us see what else we can do in it. Okay, this is the expression. This is expression for length element. So this is the expression for length element in curvilinear coordinate system. So this is the curvilinear coordinate system. Okay. Now I will again try to write it in terms of summation. So summation I running from 1 to 3, then summation over j, which is running from 1 to 3, gij dui duj. If you expand this, again you will get the same expression which we have wrote here. Gij are called as matrix coefficients. Okay, so Gij are called as matrix coefficient, and I can write a matrix for Gij. So let us try to write that matrix J. So you know how we write matrix, row into column, right? So I is representing row, J is representing column, G11, then G12, 1 means first column, this one means first, and okay, this one means first row, and this one means first column. So G13, now second row, that means 2 1 2 2 2 3, G31 3 2 and G33. So we drawn a matrix, or we wrote a matrix for Gij. Now we will think about orthogonal coordinate system. Orthogonal coordinate system. The coordinate system for which the tangent to the coordinate curves are mutually perpendicular to each other is called as orthogonal coordinate system. So in this coordinate system, unit vectors, you can say E1, E2 cap and E3 cap are perpendicular to each other. Now these are the unit vectors. So let us think about a dot product between them. If there is some vector A bar and some other vector B bar, if I take dot product between them, A bar dot B bar, I can write it as magnitude of A, magnitude of B, and then angle, cos of angle between them. Okay, so cos of theta. As you know, angle here, theta is 90 degree. So I can take dot product of E1 dot E2. It will be magnitude is 1, as they are unit vectors. E1 is unit vector, E2 is unit vector, and E3 is also unit vector. So their magnitude is 1, if I take dot product between E1 cap and E2 cap, then it will be 1 magnitude of E2 cap is also 1, and then cos of 90. So as you know, cos of 90 is 0, so this will be 0. Similarly, you can write E2 cap dot E3 cap is 0 and E3 cap dot E1 cap is also 0. Now if I take dot product of E1 cap dot E1 cap, that is with itself, so angle between them is 0, so it will be 1 into 1 cos of 0, that will be equal to cos of 0 is 1, so that will be equal to 1. Similarly, E2 cap dot E2 cap, it will also be equal to 1, and E3 cap dot E3 cap, it will also be equal to 1. Okay, why I am doing this? Earlier we saw that there is matrix coefficients, okay, you can see, and if I take an example of this coefficient, okay, so you can see here there is some h1, okay, I will take this one, so there is some h3, okay, and there was some E3 cap. You can see what we did last time. So this is the magnitude of this vector and this is unit vector along that vector. Similarly, there is dot product of h3 E3 cap, right? So you can, and similarly you can see in this case also there is h3 E3 cap dot, so this one is second, so h2 E2 cap, right? There is a dot product, so I'm going to use these dot products in that length element. So this was the expression for length element. What we see when there is a dot product with itself, that term survives, right? So you can see dot product with itself, it gives us 1. Dot product with other, it gives 0. So you can see there is G11, so this term is going to survive. G12 is not going to survive. G13 is not going to survive. This one is also going to survive, and this one is also going to survive. Others are not going to survive because we have seen E2 cap dot E3 cap is 0 in orthogonal coordinate system. Now we will write the expression for length element. So we will take another page, and that will be dl square is equal to G11 du1 square plus G22 du2 square plus G33 du3 square, whether I and j, so I can write if I is equal to j, then it will survive or it will be equal to 1. If I is not equal to j, that term will be 0, right? That term will be 0. Now I'm going to compare it with dl square. dl square, I can write it as dl1 square plus dl2 square plus dl3 square. If you compare 1 and 2, you will get dl1 square is equal to G11 du1 square, dl2 square is equal to G22 du2 square, and G3, okay, dl3 square is equal to G33 du3 square. if I take a root of this, then I will get dl1 is equal to root of g11 du, dl2 is equal to root of g22 du2, and dl3 is equal to root of g33 du3. So you can see there was a square, I took a square root and I got these terms, and there is root of g11 as there was not square of g11, so I have to take root. Now I am going to think about scale factor. I am going to write it like this: h1 du1, dl2 is equal to h2 du2, dl3 is equal to h3 du3. So what I know is this: h1 is equal to g11, h2 is equal to root of g22, and h3 is equal to root of g33. Now let us see what we got. We got h1 is equal to root of g11. So this is a scale factor and this is metric coefficient. So we got scale factor in terms of metric coefficient. Okay, we will stop here. Thank you.